In manufacturing, measuring the results of each process is vital to the success of the company. At Honda of America, they rely on statistical process control to continually monitor and improve their processes.
Statistical process control is simply monitoring the consistency and the repeatability of a specific process. It's not a complicated thing. It's really quite a simple approach to understanding what is the reliability of my process. An example of that might be torquing a bolt. In torquing a bolt, there are a lot of variables that can go wrong to cause an over-torque or an under-torque situation. In that example, if we apply statistics and understand the actual capability of the process, we can predict the failure rate within that process and make running adjustments so that we don't have actual problems occur.
Another example of Honda's use of data collection to understand its processes is the door closing speed test. This test measures how fast a door needs to be moving in order to close, but without slamming it.
Connie is preparing to measure the door closing speed on our four-door Civic. The purpose of this test is to measure the amount of speed that it takes to close the door based on a customer's perception. The first thing she'll do is she'll scan the VIN number into the datamite. The datamite is simply a handheld computer. She prepares the car by making sure it's completely sealed, and then she attaches the sensor to the rear door and the interrupter to the left side driver's door. She'll repetitively take readings of the door closing versus the door not closing until she gets within 0.1 kilometers per hour. The gauge reads in kilometers per hour. So when she reaches a point where she's within 0.1 kilometers per hour of the door closing versus the door not closing, that's the reading she records. It may take about 10 to 15 tries to get an accurate reading. She found her reading, and now she'll punch the numbers into the datamite. The door closing speed data is input into the computer, and a statistical software package is used to analyze the data. We use SPC control charts to analyze the data. At the top is an X chart, or individuals chart. As you can see, the data is consistent and stable. There is no assignable causes present, only common cause variation. In addition to the SPC charts, we also use a histogram in order to do a process capability on this particular characteristic. The histogram shows a distribution of the data based on about the last 2 weeks of data. The CPK is a capability index that tells us how well we are at meeting our specifications. Industry standard shoots for a CPK of 1.33, and we are currently meeting that.
We have a number of different ways that we collect data or do statistical process control and monitoring. Those range from equipment that automatically collects the data to a manual process where the associate's actually taking a reading and plotting it manually on a chart, to a process where we may be doing some offline inspection and actually collecting data with some hand gauges. This data is processed in a number of different ways, but the most effective method is by the associate understanding what do they do when they're out of control, when they find a point or a measurement that is not where it is supposed to be, and then they take action on it on an ongoing basis. Waiting and analyzing the result after is not always that effective, but for continuous improvement, doing it as you go is what's important.
During the door closing speed test, a result came back that extended outside the upper control limit on the control chart. This indicated that for one door on one certain car, it took an unusually high amount of speed to close the door without slamming it.
This is an individuals chart, or an X chart, showing a plot of data of door closing speeds over a certain period of time. On the chart, you'll notice an out-of-control condition at this point, meaning there is an assignable cause potentially present. This assignable cause was investigated, and it was found to be a problem with the fixture used to install the striker. The striker was installed slightly offset due to a broken fixture. When the striker is slightly offset, it will cause the door closing speed to be higher than normal. The fixture was replaced, and the data fell back into control, and it was consistent and predictable once again.
By teaching their employees to understand statistical process controls and how to immediately counteract out-of-control situations, Honda prevents problems from recurring during manufacturing and is able to maintain an outstanding level of quality control.
Se piensa que usualmente los problemas de calidad que tienen las empresas se expresan en que no se logra en promedio el valor objetivo buscado para indicadores de calidad clave de un producto o servicio. Sin embargo, habitualmente también, el comportamiento de los indicadores de calidad presenta una variabilidad mayor que el nivel adecuado y tolerable. Esta variación puede ser de dos tipos. La variación común, que es inherente al proceso como se desempeña actualmente. En su corrección está el corazón de la calidad y la posibilidad de mejorar sustancialmente un proceso. Ejemplos de causas comunes son materias primas inadecuadas, herramientas en mal estado, computadores obsoletos e inadecuado sistema de contratación de personal, entre otros. La variación especial es atribuible principalmente a los participantes del proceso. Tiene usualmente carácter temporal y su corrección depende primeramente de los trabajadores. Entre las causas especiales se pueden mencionar errores de digitación, inasistencia circunstancial de un empleado y corte de energía, entre otros. Un indicador de calidad con solo variación común se considera bajo control. Cuando tiene variación especial de alguna importancia, está fuera de control. Cuando un indicador tiene principalmente variación común, es predecible su media variación y se pueden determinar sus problemas. Pero no debe entenderse que está teniendo necesariamente un comportamiento adecuado, mucho menos óptimo, sino solo que su media y su variación están estables en el tiempo. Por ejemplo, en la producción de cajas de cereal de 400 gramos, podemos estar envasando establemente cajas con promedio de 405 gramos, con una variación efectiva y estable de más o menos 12 gramos con respecto a la media de 405 gramos, siendo que se permitía más o menos 8 gramos respecto al peso objetivo de 400 gramos. Entonces, el indicador peso estaría perfectamente bajo control, pero tendría un comportamiento inadecuado e inaceptable. Sin embargo, resulta claro que para estabilizar la media y la variación de un indicador es fundamental descubrir las causas de su variación excesiva e iniciar un mejoramiento efectivo. Para lograrlo, una herramienta muy útil es el control estadístico de procesos, SPC o CEP en español. Podemos distinguir tres grandes etapas para el mejoramiento efectivo de procesos, corrigiendo los problemas de media y variación. 1. ¿Está el proceso bajo control? ¿Es estable en su media y variación? Si no es así, es necesario implementar uno o varios ciclos PDCA para lograr que el o los indicadores y el proceso estén bajo control. 2. ¿Es el proceso capaz? Lo es cuando satisface las especificaciones para él o los indicadores en estudio, que son necesariamente externas al proceso mismo. Si el proceso no es capaz, nuevamente es necesario implementar uno o varios ciclos PDCA para lograrlo. Y 3. ¿Es el proceso suficientemente competitivo? En los mercados con mucha competencia como los actuales, un proceso puede ser estable y capaz, pero no ser suficientemente competitivo, pues presenta una variación superior a la de su competencia. Muchas veces se piensa que en ese caso el costo y el precio de la competencia serán mayores. Sin embargo, ello no es necesariamente cierto, pues es muy probable que ésta haya ahorrado muchos costos de mala calidad, como reprocesos, tiempos perdidos, descarte o reproducción de productos o servicios malos. Así, es muy posible que la competencia sea capaz de tener costos incluso inferiores a los nuestros, pudiendo bajar sus precios y reducir nuestra participación de mercado. Cuando un proceso no es suficientemente competitivo, es necesario modificar su media y reducir su variación, lo que podemos lograr mediante ciclos PDCA. Los gráficos o cartas de control son herramientas que sirven para observar y analizar con datos estadísticos la estabilidad en media y variación de los indicadores de los procesos a través del tiempo. Están formados por 3 líneas horizontales: límite de control superior, LCS, línea central, LC, y límite de control inferior, LCI. Los límites de control superior e inferior representan los límites de la variación común, y todo punto fuera de ellos representa una muy probable variación especial. Existen 2 tipos de gráficos de control: para variables, que se aplican a características de calidad medibles, tales como peso, volumen, temperatura y humedad; y para atributos, que se relacionan con características de calidad asociadas a la condición global de una unidad. Por ejemplo, si es defectuosa o no. Y se aplican a indicadores como el número y la proporción de unidades defectuosas en un periodo.
Toyota, a name associated with quality products, is considered by many to be one of the world's greatest manufacturers. This worldwide reputation is based on a specific way of manufacturing called TPS, the Toyota Production System, created to benefit Toyota's customers, employees, and products. So, what does this mean for our customers and their businesses? TPS is an expression of the Toyota Way, a philosophy containing 5 core values: Genshi Genbutsu, Kaizen, challenge, teamwork, and respect. These values are practiced and shared by all Toyota team members at every level in their daily work and relations with others. The origin of this philosophy was first conceived by Sakishi Toyoda, who invented the first automatic weaving loom. Improved versions of these looms would stop themselves automatically if a thread broke, so that product quality could be maintained and waste avoided. However, the true architect of TPS is Taishi Ono, who in the early 1950s drew inspiration from American supermarkets. He marveled at the way the shelves were hardly ever empty because they were restocked so quickly. Customers could choose the exact products they wanted in the exact quantities they wanted. Today, this is called supply-on-demand manufacturing, also known as lean production. This means that the production process will only be launched after the customer has placed an order. Once the production commences, parts arrive just in time at the factory and on the production lines, and the supplies are regulated in accordance with the exact production requirements. Like a pillar, just-in-time plays a key role supporting the Toyota production system. On the production lines, Kanban cards are employed to replenish parts just in time when stocks become low. The time it takes to produce a component or a truck is recorded, and these are called takt times. These times and work cycles are carefully monitored, then coordinated through detailed scheduling called Heijunka. Heijunka ensures that production lines run smoothly, without interruption, even when different products are being manufactured simultaneously on the same production line. TPS is all about creating efficiency. Even wasteful processes and time lost are named. They are called muda. One of the main objectives of TPS is to reduce and eliminate all muda, so that time and production are managed with maximum efficiency in a way that does not overburden either an individual, a workforce, or a machine. In consequence, all workers can concentrate on their tasks and deliver better quality products. The second pillar that supports the Toyota production system is jidoka, or making abnormalities visible. Every team member is empowered to stop the production process whenever a potential fault is detected, so a solution can be found immediately. This means that any problem is made visible on the factory floor and is displayed on the andon boards as soon as it is detected during the manufacturing process. Should a problem occur, Toyota team members are always encouraged to examine its origins and to practice Genshi Genbutsu, which means going to the source, finding the root of the problem and solving it to ensure production quality. Standardization of the manufacturing process is intrinsic to the Toyota production system's success. Developing and relying on standardized work tasks streamlines the production process and ensures consistently high levels of quality. Overall, jidoka enables Toyota to provide customers with reliable, durable, high-quality products that offer customers better productivity for their businesses and, in consequence, provide a greater return on their investment. One of the foundations of the Toyota production system is Kaizen. This means continuous improvement. Fundamental to the Toyota production process, Kaizen can be considered as both a process as well as a philosophy. At regular scheduled meetings, team members are invited to give their opinions and share their suggestions for any improvements. Inevitably, these meetings encourage and create teamwork. In a typical year in our European factories, more than 3,000 proposals for improvements are suggested and considered. Perhaps this is why the Toyota production system has also been named the Thinking People system, as it relies on total commitment from everyone involved. TPS is present in every aspect of work and builds respect. All team members are requested to play an active role in keeping work environments clean by employing the 5 S's: sifting, sorting, sweeping, spick and span, and sustain. Clean and tidy work environments benefit the entire production process. Regarding the global environment, TPS is more than willing to adhere to government standards. As the environment concerns both Toyota and our customers, our 3 European factories are all ISO 14001 certified and are fitted with the latest technologies to manufacture products that have the minimum impact upon the environment. Within the Toyota production system, safety is also of paramount importance. Most of Toyota's manufacturing sites are certified or striving for OSAS 18001 certification, so that all team members work within respected standards in a safe and healthy environment. TPS creates a safe and responsible system, producing innovative, safer products that benefit the customers and their drivers. Safer products lead to improved productivity, which creates lower overall costs for the customer. TPS, a unique production system that enables Toyota to face all challenges and manufacture products of the highest quality, products that are cost-efficient and whose delivery will be on time. TPS respects the environment and adheres to the highest safety standards. TPS, the Toyota production system, a proven world-class system benefiting Toyota's products, our customers, and our team members. Toyota Material Handling. Stronger together.